pretty introduction to finding the area between two curves. And what we're going to do this time is we're going to integrate with respect to y. So there's certain situations where you're a little bit better off to do it this way. First of all, in this example, one of the key things is these are already solved for x. So you've got these two curves. You've got this curve represented by, it's a quadratic, it's a parabola opening over the x-axis. And then you have this curve solved for x. So it's with respect to y, that's the graph that I'm highlighting, which is a parabola, again, opening around the x-axis. If you look through rectangles on this, what we're going to be doing is we're going to be looking at this intersection point and this intersection point, and then we're going to integrate from the up-down direction. So we're going to be going from here to here, from small to large, looking at those y values. So we need to figure out what this y value is and what that y value there is. Okay, all right. So we're going to set up the integral, and then we're going to integrate. Okay, one of the key things on this is when you look at your rectangles, I've drawn a couple of rectangles. We're summing rectangles in the up-down direction, starting here and then like this. And the idea is going to be the height this time, and base and height are really interchangeable. So the height we're going to use dy this time. And then for the base, so what I'm going to be using for the base is a difference between two x values. So I'm going to be taking this x value, which is represented by, f of y, this first function, whatever that is, this one right here, and then we're going to be subtracting the x value of the second function that we'll call g of y, like that. One thing that's real important on this, in this region that we're finding the area of, you're going to notice that every rectangle that we would possibly have, this curve that I've highlighted in blue is to the right of this curve that I've highlighted in yellow. So that's real important. That means we do not have to break this up into subregions. So we're going to go ahead and find the integral. And the first thing that we need to do is we need to figure out what these limits of integration are. So we need to solve an equation in order to do that. Okay, so I'm going to do this just over the side. We've got two equations, so we both solve for x. So we have x equals y squared minus 3y plus 12, and then we also have x is equal to negative 2y squared minus 6y plus 30. So again, we're going to set these equal to each other. So this is already solved for x, so that's going to plug into the x of the other equation. So what we're going to have is y squared minus 3y plus 12 is equal to negative 2y squared minus 6y plus 30. So we're going to get y values that are going to represent the limits of integration. Okay, so what I'm going to do is I'm going to move everything to the right side. So I'm going to leave this left side the way it is. I'm going to move everything here so to the left. So I've got plus 2y to the second plus 6y minus 30 equals 0. So I'm solving a quadratic equation, so I want one side equals 0. If I put together the like terms, those add to 3y to the second. These add to 3y. And then 12 minus 13 adds to negative 18. Okay, these all have a common factor of 3. So I can either factor a 3 out, or I can just divide by that constant 3 and then get a simpler quadratic to factor. So I'd have y squared plus y minus 6 is equal to 0. Then I can factor this, and this does factor. We have y times y to get y squared, 3 times 2 to get 6, and then we'd have a plus 3 and a minus 2. The inner and outer are going to add up to the y term like that. Okay, so we got two equations. We have y plus 3 equals 0, which is going to generate y equals negative 3. And that should be this limit of integration right here. So that's given the y value of that point. Okay, and then the other one we have is y minus 2 equals 0. That gives y equals 2. So that's going to give the y value at this point, which is positive 2. So those are going to be the limits of our integration. We're integrating in the y direction, negative 3 up to 2. Okay, so we've got that established now. Okay, then what we're going to do is we need to take the curve on the right and then the curve on the left and subtract those. And what we're doing is we're finding the length of this base. This value minus that value is going to give that base, okay? And we're getting x values, so that's why these two curves are solved for x. Okay, so the curve on the right is the one in blue, so that's going to be negative 2y squared minus 6y plus 30, minus the curve that's on the left, which I got highlighted in yellow, which is y squared minus 3y plus 12. Now this part right here, again, represents the length of this rectangle. And then the height of this rectangle, or the width, is represented by dy. So what I have is I've got a length times width, and I'm integrating from negative 3 to 2. Okay, so what I'm going to do is I'm going to go ahead and erase this so I can have some space to work out the integral then. So I'm going to pause this and erase all this algebra. Okay, so now we're going to go ahead and concentrate on doing the integral. A couple things that I definitely want to do on this is just kind of simplify this before we integrate it. So let's go ahead and just work this out. We got negative 2y squared minus 6y plus 30 minus y squared plus 3y minus 12. And then putting the like terms together, we're going to have negative 3y to the second minus 3y and plus 18. So that's going to be the function that we're going to be integrating on that. Now what I would suggest that we do is go ahead and factor, I'm going to factor a negative 3 out of that. You could also factor a 3 out. It's up to you. So I'm going to go y squared plus y and then minus 6. Okay, so this is actually going to be the function that I'm going to be integrating after I simplify that. Okay, so we just do this in one step. So I'm going to do the integral from negative 3 to 2. And I can take this constant out and write that as negative 3 and times the integral of y squared minus y minus 6 times dy. So I have a dy integral that I can work out. Okay, very simple power rule integral on this. So I'm going to have negative 3, and we can use the power rule for each of these parts. So that's going to be y to the third over 3. Next one you have is y to the first. So you add 1 to the exponent. That will give y to the second over 2. And then when you integrate a constant, that will be 6y. So that should be the antiderivative. And then we're going to be integrating that from negative 3 to 2 like that. Okay, so now we're set and we're ready to do the arithmetic. So we want to be really careful and make sure we have everything accurate. Okay, so by fundamental theorem of calculus, I'm going to draw like a really big bracket here. And I'm going to be evaluating at the two limits of integration. The first thing I'm going to do is work with the 2. So everywhere I see a y, I'm going to plug in a 2. Okay, so that's going to leave me with 2 to the third over 3 plus 2 to the second over 2 minus 6 times 2. And then I'm going to work with the lower limit of integration. So I'm going to replace all the y's with that and subtract. So that's going to be negative 3 to the third over 3 plus negative 3 squared over 2 minus 6 times negative 3. Now I need to just crunch out all the details of the arithmetic. Okay, so we need to do this carefully. So we have negative 3 times, this will be 8/3. Okay, this is going to be 4/2. This is going to be minus 12. And we can move over here. This is going to be negative 27 over 3. This is going to be plus 9 over 2. And that's going to be plus 18. Okay. All right, now working this out, in the next step, we're going to have -3. We're going to have 8/3 plus 2 minus 12. Okay, and then the second parenthesis, we're going to have -9 plus 9/2 plus 18. Now we're ready to just add all the fractions and stuff together then. Okay, so what we're going to have on this then, so finishing up the details here, we have -3, and this is going to be 8/3 minus 10 when we put those things together. Okay, and then I'm going to go ahead and just distribute that negative through that to get plus 9 minus 9/2 minus 18. So that's going to be -3, and let's see, let's put all these together. We'll have, that's -1, minus 18 is -19. Then I can get a common denominator on the next two terms, so I have 8/3 minus 9/2. I need to get a common denominator of 6 on that. So I'm going to multiply that by 2/2 and multiply this by 3/3. So that looks like that will give -3 times -19 plus 16/6 minus 18/6. So that looks like -3 times -19 minus 2/6. Okay, and moving that through one more step, it looks like we have -3 times -19 minus 1/3. And then I can do a distributive property, multiply this out. So -3 times -9 is 57. And then plus 1/3 of 3 is 1. So it looks like we have an area of 58. Okay, so I think I may have made one mistake in the calculation. That's what you got to be so careful about. Looks like I made a mistake right here. That should be 27/6. So let me go ahead and let me correct that so we can make sure we get the right answer here. It's so easy to mess up on arithmetic if you get to going through these kind of quickly. So I've got -3 times -19 plus 16/6 and then minus 27/6. So that's going to be -3 times 19, and then 26 minus 27 is minus 11/6. And then if I multiply by 3, I'm going to get -3 times, and then that's a -19. It's going to be 57, and then plus 33/6, like that. Okay, well actually this fraction right here reduces, it looks like, so you can reduce that by 3. So you would get 57 plus 11/2, and then we should be able to get a common denominator and finish this up then. Okay, so I got 57/1 plus 11/2, and when I put that together, and then I can introduce the common denominator. So it looks like I get 114/2 plus 11/2. So it looks like 125/2. So that's the answer of the problem. Okay, now the TI doesn't check integrals this way. The TI is programmed to only do integrals with respect to x. Okay, sorry for the yawn there. Okay, so I've looked at everything on that. Everything should be correct. Okay, so now I'm going to move on to the next one here. And going to look at setting up this integral right here. Okay, now what you have on this is two curves. The first curve is going to be this curve right here. Okay, and then the second curve, what we have is this one, and that's going to be this curve right here. So we got actually two regions that we need to do on this thing. Let me erase that. That kind of makes it look messy. So the idea, if you look at this for a minute, is we got two regions we got to consider. This region right here, the function on the right is this one, and the function on the left is this one, but then up here it changes. Then this becomes the function on the right, and that becomes the function on the left. So we actually got two regions. I'm going to call that region 1 and that region 2, and we're going to integrate this in the y direction. So we need to find actually this intersection point, and this intersection point right here. So we need to find all of those y values. We don't have to worry about the x values because that's going to be the limits of integration that we're going to break up. Okay, so again, like we do on this, we just solve this system of equations. So we have x equals y to the third minus 4y squared plus 3y, and the other curve solved for x is x equals y to the second minus y. See, these are solved for x, so it's set up for a dy integral. Okay, set these equal to each other. Again, this is what x is. That plugs into the x of the other equation. So we'll have an equation that we need to solve. We're going to be working with y to the third minus 4y squared plus 3y is equal to y to the second minus y. So we need to get that taken care of. Okay, let's get everything to the left side. So we have y to the third minus 4y squared plus 3y minus y to the second plus y equals 0. Okay, then what you want to do is any like terms go together. So negative 4y to the second minus y to the second is minus 5y to the second. And then 3 plus 1 is going to be plus 4y is equal to 0. Okay, this one you can factor a y out. You have a common factor of y. So take that out. That will leave you y squared minus 5y plus 4 equals 0. Then this trinomial looks like it factors, so that'll be kind of nice. So that's going to factor as y and y, and you got to have 4 times 1 to get the 4, and then you got to have 2 negatives to add the 4 and the 1 up to negative 5y. So that means you have y equals 0. This gives y equals 4. And that gives y equals 1 as 3 of the zeros of the polynomial. So clearly what we have is y equals 0 is that y value. Y equals 4 looks to be this y value. And y equals 1 looks to be that y value. So what we've done is we've got our limits of integration. We can now kind of get our integral set up. So I'm going to go ahead and set up the integrals. So the area of region 1 would be represented on the integral from 0 to 1. So we're going to be integrating from here to here, 0 to 1. The curve on the right is the one that's in black, which is y to the third minus 4y to the second plus 3y. The curve that's on the left is represented by the one in red, which is y squared minus y times dy. Okay, now again, when you have a rectangle on this, dy is represented by the width or the height of the rectangle, and then that base is represented by the difference between these two curves. Okay, so we're going to work that one out, and then the second integral we're going to work out is region 2. We're going to be integrating from 1 up to the y value of 4. So we integrate from 1 to 4. Now the curves are backwards. The curve on the right is the first one. So we're going to say y to the second minus y. Subtract the curve on the left, y to the third minus 4y squared plus 3y times dy. And again, the reason we do it in that order is because we need a positive value of the width of this rectangle, and if we take the big number minus the small number, we're going to get a positive value. Okay, so now we're set up. We got our integration set up. Now we just need to work out the calculus and the arithmetic. So I'm going to go ahead and erase this so we can get everything kind of worked out here. So let's work first of all on this integral. And to begin with, let's go ahead and let's simplify this. So we have y to the third minus 4y to the second plus 3y minus y to the second plus y. Collecting the like terms, we have y to the third minus 5y squared plus 4y. Okay, so what we're going to end up doing then is the simplified version of this integral is 0 to 1, y to the third minus 5y to the second and plus 4y times dy. So we're going to do that integral. And now notice, since we subtracted this backwards, okay, all that's going to happen on this is when we do simplify this expression, we're just going to have negative y cubed minus 5y squared plus 4y dy. You can crunch out the details to verify that, and then you can bring that negative out, and that will kind of help a little bit with the antiderivative. Okay, so we are set up now, and we're pretty much ready to go here and ready to get this one put together then. Okay, so I'm going to go ahead and focus a little bit my efforts on doing this first integral right now. So I'm going to take this integral right here, and let's get that one worked out. Okay, so we're going to be integrating. You can do this integral in your head. It's a power rule integral. So that antiderivative is going to be y to the fourth over 4 minus 5y to the third over 3 plus 4y to the second over 2. And we're going to be integrating from 0 to 1. Okay? And we can simplify this a little bit so that we get y to the fourth over 4 minus 5y to the third over 3 plus 2y to the second, integrating from 0 to 1. Okay, so let's go ahead and do that. Work out the fundamental theorem. So I'm going to draw like a really big bracket and 2 big parentheses and evaluate the limits of integration. Okay, so first of all, plug the 1 in. The 1 is going to plug in everywhere you have a y. So that's going to leave us with 1 to the fourth over 4 minus 5 times 1 to the third over 3 plus 2 times 1 to the second. So that crossed out and made that a 2. Now we're going to plug in, which I love when I see a 0 there. That'll help us out tremendously. So plug that in. So we're going to have 0 to the fourth over 4 minus 5 times 0 to the third over 3 plus 2 times 0 to the second. So that's the arithmetic that we then need to work out. Okay, so working this out, we're going to have, this is 1/4. This is going to be 5 times 1 or 5/3. And this is going to be 2 times 1 or 2. Okay, like that. And then all this stuff over here, of course, is going to be 0. You have 0 over 4 minus 0 over 3 plus 2 times 0. So all that's going to just kind of cancel. So what we're really working with is 1/4 minus 5/3 plus 2. And we can get a common denominator and get this put together. So that's going to be 1 over 4 minus 5 over 3. Put the 2 over 1. The common denominator is 12. So I'm going to multiply this by 3 over 3. This one by 4 over 4. And this one by 12 over 12. So if I work out the details, I get 3/12 minus 20/12 plus 24/12. Okay, so that will be 27 minus 20, or that looks like 7/12. So that's what the value of the first integral is 7 over 12. And that leaves us to work out the region of the second thing. So I'm going to work that out and just kind of slide this up here and work out that region. Okay, so let's work out the second integral. Okay, now one thing you can do on this is you can bring the negative out. So this one you would have negative, again, y to the fourth over 4, just doing a power rule integral, minus 5y to the third over 3, plus 4y to the second over 2. And we're going to evaluate this one from 1 to 4. Okay, so this is going to be the same thing as a negative y to the fourth over 4 minus 5y to the third over 3 plus 2y to the second, evaluated from 1 to 4. Okay, so let's go ahead and work out the details there. Okay, so I'm going to draw, like I'm kind of used to doing a big bracket. When I do the fundamental theorem, I'll be evaluating the upper limit and subtracting the evaluation of the lower limit. Okay, so let's start by plugging in the upper limit of 4. Okay, so that's going to give, we've got a minus here, and you got to be careful about that minus. Okay, then we're going to have, looks like 4 to the fourth over 4, minus 5 times 4 to the third over 3, plus 2 times 4 to the second. Now plug in the lower limit of 1 into the y values. So that's going to give 1 to the fourth over 4, minus 5 times 1 to the third over 3, plus 2 times 1 to the second. Okay, then we'll start crunching out the details here and carefully work out the arithmetic, then we can put together our final result. Okay, so this is negative, and see, 4 to the fourth is 256, so that's 256 over 4, 5 times 16 over 3, plus 2 times 16. Okay, so that's what that's going to be, minus, and then this is 1 over 4. This is 5/3, and this is 2 times 1, so that's 2. Okay, working this out, this is 16. Okay, this is 16 times 5 is 80, so that's going to be 80 over 3. And then this is going to be plus 32. And then over here I'm going to distribute the negative to get minus 1/4 plus 5/3 minus 2. So I've got a negative 16 minus 80/3 plus 32 minus 1/4 plus 5/3 minus 2. Okay, so now let's just kind of put everything together that we can inside the bracket. Just saw a little mistake. Gosh, it is so easy to make mistakes on these problems. So if I did 4 to the third, this right here is 64. Okay, so then you're going to do 5 times 64. So we've got to work that out. And that's 320. Okay, so I need to correct this to 320. And correct that one below that to 320 over 3. Gosh, you got to be so careful on these things. 320 over 3. Okay, now let me make sure. I think I got everything okay now. Okay, so I'm going to put together some like terms. So let's see, we have 16 and 32 is 48. Minus 2 is going to be 46. So I have negative 46. And then I can put these two things together. So if I put together negative 320 thirds and 5/3, that should be negative 315 thirds. Okay, then I've got the minus 1/4. Like that. So I'm going to get a common denominator and kind of get this put together. So I'm going to do 46 over 1 minus 315 over 3 minus 1/4. We have a common denominator of 12. So I'm going to multiply this by 12 over 12. I'll multiply this by 4 over 4 and this by 3 over 3. Okay, so let's go ahead and slide this up, and then let's go ahead and get this finished up. Okay, so it looks like we're going to have a negative. I'll use my calculator to help me a little bit with this. So I got 46 times 12, which is 552 over 12, minus, and then I'm going to do 315 times 4. It's going to be 1260 over 12, and then minus 3 over 12. Okay, work that out. Let's see. Let's just go inside. 552 minus 1260 minus 3 is going to give, we have a negative 711 over 12. So the final answer is 711 over 12. Okay, so we've got our two regions now. So what I need to do then is just put this area together. So I'm going to kind of zoom in on this just a little bit. And what we have is we had this region, and we got this one. Okay, so the total is going to be 7/12 plus 711 twelfths. So that looks like that would be 718 twelfths. And then we can reduce that fraction. Okay, I think I can at least divide by 2. So if I do 7/12 divided by 2, I'm going to get 356 over 6. Okay, then I can divide by 2 again. Okay, so if I do 356 divided by 2, you get this, so that's going to be 178 over 3 appears to be the final answer to the problem. Okay, so that's the answer right there. Okay, a couple of things I want to mention on this. Again, the y integral, if you're doing a dy integral, respect to y, the graphing calculator is not going to help you on that. But a couple of things that kind of come in handy on these sometimes is, like if we got down to this point right here, I mean, you could do all this in your calculator like this in one step. Your calculator is a great tool for this kind of stuff. So you can go 16 minus 320 over 3, and then plus 3 halves. And then, now hold on, that's 32. I can't see worth of crap. And then minus 1/4 plus 5/3. And then minus 2. Okay, now that'll give decimals, but what you can do is you can do math fraction, press enter, and it takes it back to what we have then. Okay, so you can use this to check which. So what I'm saying is you could go check and, at this point, and just use your calculator to see if this is right. So if I go 16 minus 320 over 3, and then plus 32 minus 1/4 plus 5/3 minus 2, I get this decimal equivalent. Okay, now that negative there makes that positive, so you're going to have 59.25. Then if I go math fraction, that converts that to 237 over 4. And actually, that's what this is. 237 over 4 is the same thing as 711 over 12. If I go 711 divided by 12, so I get the same thing, then I can go math fraction like that. So you can use that to verify any part of the problem, even the last step. I mean, if you just go 7/12 plus 711 over 12, this gives a decimal answer. Then you can go math fraction, and it gives 359 over 6. Okay, like that. So I may have made a mistake on that. Looks like I got everything calculated there okay. So 7/12 plus 7/11 over 12 reduces down to 359 over 6. So it does look like I made a little mistake on the very end of this. So let me finish this. And that's why I recommend that you use your calculator to kind of help you, because this arithmetic's really tedious. So this is 718 over 12. Okay, now I think you can divide both of those by 6. Let's find out. 718 divided by... No, I think that's not right. Let's see. Hold on. So let's see. 718 divided by 6. Oh, this thing doesn't work. Okay, hold on just a second. Let me fix this. Okay, so we got 718 divided by 12. Okay, you can divide by 2 for sure. So if you do 718 divided by 2, you're going to get 359. And then 12 over 2 is going to be 6. So that's actually the final answer right there. Okay, now again, what you can do is you can go 7/12 plus 711 over 12, get that answer, then go math fraction, then it'll give this answer. So use your calculator to help you with stuff like this. I mean, you want to be able to do stuff by hand and with your calculator to help, but it is so easy to make a mistake when you have this many steps on a problem. Okay, now what I'm going to do is I'm going to move to the next problem here, and I'm going to finish up this example 10. Now we're going to do a graph on this one. I didn't give you a graph on this one, so the expectation is that we would use our graphing calculator to get this one put together. So we're going to go ahead and we're going to first of all plot y equals e to the x. So you would go second ln to get that to come out, e to the x. Okay, remember that's a curve. E to the x is a exponential curve that's going to do something like that. Then in y2 we're going to do 2 e to the negative x plus 1. And then that will be a curve that's going more like this. So let's we're going to look at bounding this by x equals 0. Let's start the window from, say, 0 to 10 and scale by 1. And let's do the y from 0 to 10 by a scale of 1. Now let's see what we got going on in the problem. We may have to adjust that. So that's e to the x, and then that's the other region like that. So see, you're going to be looking at this little region here. So I'm just going to adjust the window so it goes 0 to 3. So let's go do something like this. Let's go 0 to 3, and then maybe something like 0 to 4, like that. Graph that so we'll have a pretty good picture. So there's e to the x. Here comes out the next graph. So that's a pretty good picture. We're looking at this region right here. Now I'm going to take a quick screenshot of this so we can kind of refer to this as we go. And then we'll build our integral, and then we can find the area under the curve then. Okay, come on, OneNote, come back up. There we go. Okay, so let me paste this, and I'll put the calculator to the side here for a minute, and then we'll kind of consider what's going on in the problem. Okay, so I'm going to label this. This is y equals e to the x would be that curve, and then this curve is y equals 2e to the negative x plus 1, and we are going to be looking at this shaded region right there. So we'd have to kind of decide, do we want to use a y integral, do we want to use an x integral? And the thing that we have on this is we've already got x equals 0. If we can find this intersection point right there, then we could integrate from 0 to that x value there. And that is going to be the way I'm going to do this, because this curve is always above this curve. So we don't have to break this up into two subregions. So the first thing we got to do on this that's fairly challenging actually is we got to find the intersection point. So let's focus on that before we even get into setting up the integral and doing the calculus. So we're just going to set these things equal to each other. Here, this is y, e to the x is going to plug in there. So we're going to solve the equation e to the x is equal to 2 e to the negative x plus 1. Okay? So here's the way I'm going to do this. There's more than one way to do this. I've got a negative exponent. So I'm going to write this as 2 over e to the x plus 1. And then I'm going to get rid of my fraction by multiplying both sides by e to the x. Okay, that's going to be my thought process. This thing's probably going to be factorable. Okay, remember you add the exponents here. When you're doing a problem like this, that's no different than having like e to the second times e to the third. That's e to the fifth. So this is going to be e to the 2x. When you multiply this times this, the e's are going to cross out, leaving 2. And then you're going to have plus e to the x like that. Okay, now this is actually quadratic in form. So I'm going to move everything to the left side and get e to the 2x minus e to the x minus 2 equals 0. And I'm going to solve this by factoring. So I'm going to draw two parentheses, and let me show you how this works. The first term is e to the x. So that means what you're going to put in your factors are e to the x times e to the x. And then the last term is 2. So you're going to work with 2 and 1. And then see this inner term from multiplying out would be 2e to the x. This outer term would be 1e to the x. And you're trying to make that add up to negative e to the x. So you have to have a negative and a plus there. So you're going to have, the factoring is going to go like that. Okay? Then you got to set each factor equal to 0 and solve. Okay, so that factoring right there can be kind of a challenge sometimes for students in this level of class. So what we're going to do here is set each factor equal to 0. We're going to solve that equation, and then we're going to solve this equation, and we're going to see what we get. Okay, so starting over here, if I subtract 1 from both sides, I end up getting this. Now, that has no solution. Okay, if you take e to any power, you will never get negative 1. Even if that's a negative power, you're going to get a positive number. Another thing that you could do if you didn't see that right away is you're kind of used to taking an ln of both sides. Problem is you can't take an ln of a negative number, so that one has no solution. So we don't need to worry about that. That generates nothing. So now we go over here, we add 2 to both sides, and then we're going to do the ln of both sides. So I take ln of both sides. Remember, we have the property that says we can move the exponent in front to get x times ln e equals ln 2. ln of e is 1, so this is x equals ln 2. So that means this intersection point right here has an x value of ln 2. Okay, like that. That's all we care about is the x value on that. Now, if you wanted to find this y value, well, what you could do is you could just take this function and plug it in. So you could go y equals e to the ln 2, and we have a property that says that answer would be 2. The property that you usually learn in college algebra is p log base p of x is equal to x. So as long as this base matches that base, that's the solution. So you get this intersection point like that then. So that's the first thing you got to study on this problem is how do I get that intersection point? So that's the first thing that we need to focus on for a few minutes then. Okay, now what we're going to do is we're going to build our integral and we're going to integrate and see if we can get an answer to the problem. Okay, so the integral is going to be from 0 to ln of 2. The curve on top is this one, so we're going to say 2e to the negative x plus 1 minus the curve on the bottom is e to the x times dx. So we're going to integrate this one with respect to x, and this shouldn't be that bad of an integral because it's got e to the x in it. Okay, so let's go ahead and let's kind of look at this at the side here. We're going to do the integral of 2e to the negative x plus the integral of 1 minus the integral of e to the x. Okay, this one is going to be 2e to the negative x, but you're going to have a negative there. The integral of e to the negative x dx is going to be negative e to the negative x. Okay, and then do the derivative in your mind to make sure that that is right then. The integral of 1 is going to be x. The integral of e to the x is e to the x. So this right here is your antiderivative that we're going to evaluate. So if I go back over here, we have negative 2 e to the negative x plus x minus e to the x, and we're going to evaluate that from 0 to ln2. Okay, so I'm just going to kind of keep going this way so I can so you can kind of see everything that I've done on the problem. Okay, so to begin with, we're going to evaluate at the upper limit, ln2. Everywhere you see an x, you're going to plug that in. So that's going to be negative 2. And I'm going to go ahead and write that as 1 over e to the x. Okay, then I'm going to plug that in. So I'm going to go ahead and write this like this. Let me just write one more step, and then we'll evaluate this. So let's write this as negative 2 times 1 over e to the x plus x minus e to the x, and then go from 0 to ln2. Okay, so now when we evaluate, we're going to have negative 2 times 1 over e to the ln2 plus ln2 minus e to the ln2 minus, and then do the lower limit, 0. So that's negative 2 times 1 over e to the 0 plus 0 minus e to the 0. Okay, so we need to crunch out the details and see what we get. So I'm going to move this over here. So we have negative 2. Now see, this thing right here is 2. So you'd have 1 over 2 there. Okay, and then the ln2, so that takes care of that. ln2 is a constant, so just leave that alone. Okay, this thing again is going to be 2. It's a basic property. And then we're going to have minus. This is going to be negative 2 times 1 over 1 plus 0. And then e to the 0 is going to be minus 1 like that. Okay, so if we go inside the brackets, that's going to cancel. That's going to leave us negative 1 plus ln2 minus 2. I'll take care of that. And then minus, this is negative 2 plus 0 minus 1. So now we're pretty close to getting this done. So it looks like we'll have those go together to make negative 3. So we have negative 3 plus ln2. Distribute the negatives, so you'll have plus 2 plus 1. So it looks like 3 and negative 3 cancel out. So it looks like the answer of the problem is ln2. Okay, and that one could be checked and verified pretty easily with a calculator. I'm going to go ahead and do that on this one. Since it is a dx integral, we should be able to easily go ahead and do that then. So if you want to check this on a calculator, go back to the integral that we're evaluating. So this is the integral that we just got through doing that finds the area under the curve. So what you'd want to do is graph this. Don't make two graphs, just graph the function that's represented by the integral. So you'd say 2 e to the negative x, like that, okay, plus 1, like that, and then minus e to the x, and we can use the same window and just see what comes out. Okay, so, well, we need to find this area here, so what we're going to do is go second trace, option 7. Lower limit was 0. Upper limit was ln2, so I just put in ln2. And then we're going to get this value, which is approximated by 0.69314718. Now I'm going to clear that. Now let's just see, our answer was ln2, so let's see what the ln2 is and see if it's the same thing. So I go ln of 2 is going to give the same thing. Okay, so that checks and verifies with technology that we have a correct answer to the problem. Okay, so we're going to do one last thing, and we're going to do this integral. And then I'm going to set up a few other integrals on here. So we're going to go ahead and look at this one and get this one worked out. Okay, so this time, the thing on this one is we're going to find the integral with respect to y. These are already solved for x, so this one's kind of set up nicely. So the key thing is, if you're going to integrate with respect to y, you need to find that intersection point, you need to find this intersection point, and you need to look at the y values, because you're going to integrate from that y value up to that y value. So you're stacking rectangles like that. So one of the things you want to do, if you're going to do a y integral, you want to make sure that this function on the right is always to the right of the one that I've got in red, and it is. So that will make this a fairly easy problem. When in doubt, just kind of look at a few rectangles. So if I was to do a rectangle on this, here's an example of a rectangle. What you would end up having on this, see, is that would be dy, that dimension would be dy, and then the length of this rectangle would just be this x value minus that x value. Okay, and you'll find on all the, since the graph represented in black is always to the right of the one represented in red on this shaded region, then we don't have to work with subregions. Okay, so we're going to go ahead and set up our integral. So the first thing we got to do is we got to find these two intersection points. So let's get that taken care of first of all. So we're going to set the two curves equal to each other. So we're going to take 2y and we're going to set it equal to this. So we got the equation 2y equals y squared minus 3. That will be a quadratic equation. Just move the 2y to the other side to get y squared minus 2y minus 3 equals 0. You can solve this by factoring to get y and y, 3 and 1 with a minus and plus. So that's going to give solutions y equals 3 and y equals negative 1. Okay, so clearly if you look at the diagram, this is negative 1. That's what that one is. And then this one is 3. So that's going to give you the limits of integration. So we're going to integrate from negative 1 to 3. We don't have to figure out what those x values are. That's really unnecessary in the problem. If you wanted to, you would just go x equals 2y because of this function, and then 2 times negative 1 would be negative 2. So that's what that is. And then this one, you would have x equals 2y. So 2 times 3 is 6, so you would have that intersection point like there. But it's unnecessary. Okay, now in our integral, we're going to do the curve on the right. The curve on the right is 2y. Subtract the curve on the left, which is y squared minus 3 times dy. So that's going to be the integral that we're going to work out then. Okay, so let's simplify this expression down here. So we're going to have the integral from negative 1 to 3. I'm going to go like this. I'm just going to put this as 2y minus y to the second plus 3 times dy. Okay, then we should be ready to go through and integrate this one then. Okay, so let's do the antiderivative. We can do the antiderivative in our head on this one. Okay, so I'm just going to kind of do this at the side. What we're really doing is the integral of 2y dy minus the integral of y squared dy plus the integral of 3 dy. This one's going to be 2y squared over 2. This one is going to be y to the third over 3. And that one's going to be 3y, applying a power rule for the integral. So our antiderivative is y squared minus y to the third over 3 plus 3y. So that's what we're going to go through and evaluate with the rest of the problem. So we're going to evaluate y squared minus y cubed over 3 plus 3y, and we're going to evaluate that from negative 1 to 3. Okay, so I'll put it together. Let's do the arithmetic. So we're going to first of all start by plugging in the upper limit into y and working out the arithmetic. So that's going to be 3 to the second minus 3 to the third over 3 plus 3 times 3. Now evaluate with the lower limit, and that's going to be negative 1 to the second minus negative 1 to the third over 3 plus 3 times negative 1. So that's the arithmetic we need to work out. Okay, so this is going to be 9. This is 27 over 3, so that's 9. 3 times 3 is 9, so that will take care of that. Okay, going over here, that's positive 1 minus, this is negative 1/3, and then this is minus 3, like that. Okay, putting this together, those will cross out, so that's going to leave you with 9. And then I'm just going to write minus 1. Actually, let's kind of do this like this. We can put these like terms together. So I'm going to have 1 minus 3 is negative 2. So that's going to be negative 2 plus 1/3. Then I can go through and get 9 plus 2 minus 1/3. So that's 11 minus 1/3. And if you get a common denominator, you can put that over 1. That will be 33/3 minus 1/3. So that final answer should be 32/3. Okay, so that is the final answer to that problem. Okay. Okay, now we're going to move to one other illustration and then set up one more integral. Okay, this one again, we're going to do the same problem. Okay, the idea on this was we did this problem and we did an integral with respect to y. So we're going to do the same problem again, but we're going to set this up with respect to x. Okay, so the first thing you got to do on this is you need to solve these two equations right here for y. Okay, so let's just kind of do that. We have x equals 2y. If you divide by 2, you're going to get y equals x over 2. So instead of looking at that, we're going to look at this. Same thing here. We're going to solve this. So you can add 3 to both sides. So you have x plus 3 is equal to y squared. And then when you do a square root of both sides, you got to be cautious about the plus or minus. So you actually have y equals plus or minus square root of x plus 3. Okay, so if you're going to do a dx integral on this, your two functions need to be solved for y when you do this. Okay, so we need to get that done. And now what we need to do is kind of figure out how we're going to break up this region. Now, what we're doing is you're going to, of course, have to look at the intersection points. So we're going to need to find these two intersection points. And then we're going to have to think about how we break this up. So what would happen on this, basically, if you're going to do this, we also need to find this vertex of this parabola. So what we're going to have to do on this is, if you look at this, the curves are kind of different. If you look at this part right here, and I'm going to blow this up just a little bit, magnify this so you can see what I'm talking about. That's going to be a region we have to do, okay? And see, the curve is the same curve. But technically, this curve right here is going to be y equals plus square root of x plus 3. And that curve on the bottom is going to be y equals negative square root of x plus 3. That comes from solving this equation for y. And then when you get to this region here, this curve is going to be on top of the curve I've got represented in black. So you do have to do two regions on this problem. And we're going to have to integrate. We need to find that x value, so we can integrate region 1. And region 2 is going to be from this x value to that x value. So what you need to go ahead and do is you need to solve these equations and work these two things out then. Okay, so we need to focus for a minute on finding all these points that we need. The first thing I'm going to do is I'm going to focus on finding this point right here. That's actually the vertex of this quadratic. So if you look at this function, y equals plus or minus square root of x plus 3, we want to find a y-intercept, or sorry, an x-intercept. We find an x-intercept, we let y be 0. Okay, so I just do this. I can solve this equation in my head. If I square both sides, I get 0 equals x plus 3. And if you solve that equation, you get x equals negative 3. So that x value is going to be negative 3. That's the vertex on that one. Okay, now we have to find this intersection point. So we got to find the intersection between these two curves. So I'm going to work with this, and I'm going to work with this, just setting them equal to each other. So I'm going to say x over 2 is equal to, and see, we're using the negative part of this curve right here. So we got to intersect this thing with that thing. So we're going to set that equal to negative square root of x plus 2 to get that. Well, again, what you can do on this one is you can solve this equation by squaring both sides. It's a radical equation. So you'd have x squared over 4 is equal, and then that negative will become positive, and then you'll have x plus 2. Okay, like that. Okay, one thing you can do on this, it's a quadratic equation, so you could certainly on this one go through and solve this equation. You could multiply both sides by 4. I have to cross out the 4, so you'd end up having x squared is equal to 4x plus 8. Okay, like that. So that would be x squared minus 4x minus 8 is equal to 0, like that. Just noticed I did the wrong thing here. Okay, what I did is that's an x plus 3, not an x plus 2. I was coming out with a kind of a freaky answer, so I was kind of beginning to question myself. All right, sorry about that. God, it is so hard to do anything on these problems without making some little bonehead mistake. And I do that a lot of times, not because I don't know what I'm doing. It's just because I'm blind and can't see what I'm doing half the time. Okay, so we're going to do that using the same thing. So we get x squared equals 4x plus 12. So that's x squared minus 4x minus 12 equals 0. And then that factors as x and x, 6 and 2, with a minus and plus. So that gives x equals 6 and x equals negative 2. So clearly this negative 2 is representing this thing right here. Okay, so we got that. All right, now the next thing we need to do is we need to find this intersection point. So what we're going to do with this one is we're going to take the curve in black, which is x over 2, and we're going to set this equal to the curve in red, which is the upper part of the square root function, square root of x plus 3. Okay, now if you look at this, this is going to give 6. Okay, that's going to give this curve right here. If you solve that equation, you're going to get x equals 6 by using the same strategy. Okay, so we've got our intersection points. Now what we got to do to finish this up is we need to set up the integrals for our two regions then. So the area of region 1 is going to be the definite integral from negative 3 to 2. I'm sorry, negative 3 to negative 2. The curve on the top is positive square root of x plus 3. The curve on the bottom is negative square root of x plus 3. Okay, times dx. So that's going to be the integral that we do to find that region. And then the area of region 2 is going to be the upper curve on region 2 is going to be, again, we're going to go from negative 2 to 6. And then the upper curve is going to be square root of x plus 3. The lower curve is going to be the black line x over 2. So those will be the two integrals that you would have to work out to get your exact answer to your problem then. Okay? So that's what we're going to work on next, is that integral. Okay, so what I'm going to do is I'm going to erase this stuff so I can have a little bit of room to focus on doing these two integrals then. Okay, so let's start by doing this integral right here. So when we do this integral, we've got the integral from -3 to 2. Now see, that's would be plus, so that would actually be 2 times the integral of x plus 3 times dx. You can bring the 2 out to get 2 times the integral of x plus 3 dx. Okay, that looks like a u substitution integral to me, so I'm going to let u be x plus 3. Okay, then we're kind of hoping that du will be dx. So let's do that. So du is indeed going to be 1 times dx, or just dx. Okay, so what we'll have is we'll be working with this integral. We're going to have 2 times the integral, and then replacing u there, I'm going to write that as u to the 1/2 times du. We're going to change the limits of integration now. So we have u equals x plus 3, so plug in -3. So -3 plus 3 is 0, so that changes that. Plug in the 2, so we have u equals 2 plus 3, so that's 5. So we're going to need to work out that u integral, which is pretty simple. So we have 2 u, this is power rule, you want to add 1 to that. The result of that's 3/2, so you're going to divide by 3/2. Then integrate that from, or evaluate from 0 to 5. So that's 2 times 2/3, u to the 3/2, evaluated from 0 to 5. Okay, so that is going to be 4/3, and then you're going to do 5 to the 3/2 minus 0 to the 3/2 to evaluate that integral. So we're going to have 4/3. This piece right here is going to be square root of 5 to the 3rd, and then minus 0. So that's 4/3. You can break this up as square root of 5 to the 2nd times square root of 5. And then that will be 4/3 times 5 times radical 5. So it looks like that is 20/3 times the square root of 5. That's what the value of that integral is then. Okay, so we've got that piece right there worked together then. Okay. Now what we can do on this next one is we got to also work out this integral. So I'm going to slide this up a little bit so we can now just sort of focus on this integral right here. Okay, so what I'm going to do with this one is I'm going to break that into 2 parts. I'm going to do the antiderivative of these, and you can do a u substitution, or you could even do this. See, if you're doing the integral of x plus 3, see, we already did that. Okay, when we did this integral right here, our u integral, when we did that, ended up being u to the 1/2. Like that, and then that is u to the 3/2 over 3/2, so that is 2/3 u to the 3/2, and then you can plug back in u, and u is x plus 3 to the 3/2. Okay, so what I'm saying is you could go ahead and do that like that if you wanted to, because we've already done that integral by u substitution. We could even do this if you wanted to. We can change the limits of integration on that and do that, and go ahead and do that integral. I'm just going to go ahead and do this then. So when I did the antiderivative of the square root of x plus 3, then I should get this. Okay, so our antiderivative on this is going to be, I wish I wouldn't have erased that because I just forgot what I wrote. Okay, there it is. Okay, so this antiderivative is going to be, of this part, is going to be 2/3, and that's square root of x plus 3 to the third, minus, and then this antiderivative would be 1/2 x to the second over 2. Then we're going to evaluate that from -6 to -2 to 6, like that. Okay, now I'm going to erase this so I'll have a little bit of room to complete this then. Okay, all right, so let's start with the upper limit of integration, plugging in there and plugging in there. Okay, so we're going to have 2/3 square root of 6 plus 3 to the third minus 1/4 6 squared, and we're going to plug in the -2 into the antiderivative, so that's going to give 2/3 square root of -2 plus 3 to the third minus 1/4 times -2 to the second, like that. So this is going to be, looks like 2/3 times the square root of 9 to the third, which is nice, minus 1/4 times 36. Then over here we're going to have 2/3 times the square root of 1 to the third, minus 1/4 times 4. Okay, so what we'll have here then is 2/3. Okay, now you can break this up as 9 to the second times square root of 9, like that if you want to. And then this is going to be 9 there. This is square root of 1 is 1, so that's minus 2/3. 4's cross out, so that's minus 1. So it looks like we have 2/3. Square root of 9 squared is 9. Square root of 9 is 3. Minus 9. And then I'm going to write this as minus, or let's just distribute the negative through the parenthesis to get minus 2/3 plus 1. Like that. So let's see, if we do this now, 9 over 3 is 3, so this is 3 times 3, 9 times 2 is 18, so we have 18 minus 9, minus 2/3 plus 1, so that looks like that is 9 plus 1 is 10, minus 2/3, so I can get a common denominator. To get 30/3 minus 2/3, so that appears to be 28 over 3. Okay, so those would be the values of those two integrals, and then we can add those two basic areas together. Okay, so I made a little mistake on this one. The answers to these last two problems are supposed to be the same, and this is just, I can't see. All right, I need to be integrating from -3 to -2, so notice over here, when I was doing this upper integral right here, this is where I messed up. Gosh, I don't know what I got to do to keep from making these silly mistakes. Okay, so that's a -2. All right, so if that's a -2, that means that this part right here, when we change the limit of integration, we should have -2 plus 3 is equal to 1. So our u integral, we should be integrating from 1 to 5, actually. So I need to correct that. Gosh, this makes me so mad. Okay, so from 1 to 5, so that means that this thing right here should have been a 1. Like that. Okay, and let's see, all this is okay here, but this thing right here, if you do 1 to the 3/2, 1 to any power is 1. So that should have been 1. Now let me just erase this, and then we'll put the whole thing together, and I'll show you I get the same answer. Okay, all right. So we have 4 to the third here. Hopefully I get the same answer. Okay, so let me get this fixed, and I'm just going to kind of go over here and redo these limits of integration, because that's where I messed up on. Okay, so Okay, what's going to happen here then is plug in -2 in here. So -2 plus 3 is going to give 1. Plug in -3. -3 plus 3 is going to be 0. So in this u integral, I should have went from 0 to 1. Okay, so let's do that. Let's do it carefully. So we bring down the 2. The antiderivative of u to the 1/2 is u to the 1/2 plus 1 divided by the result, which is 3/2. And then we're going to integrate from 0 to 1. Okay, so that is 2 times 2/3, u to the 3/2, integrated from 0 to 1, so that is 4/3, u to the 3/2, 0 to 1. Okay, now I'm going to have 4/3 times 1 to the 3/2 minus 0 to the 3/2, so that's 4/3 times 1 minus 0, so that's 4/3. Okay, so here's what I should have got for my result. Okay, this is the result of the first integral. That's 4/3. Okay, the result of the second integral is 28/3. Like that. So that means the total would be 4/3 plus 28/3, which is equal to 32/3. And that is the same answer as the previous problem. I'm just showing you a different way to do that. Okay, so notice on this we got 32/3, and on the problem I just worked out using this technique, I also got 32/3. Okay, so that is your final answer right there. Okay, God, I've made a lot of mistakes on this. Just mostly arithmetic and visual things. Can't see. Okay, so let's see. This next thing, we're just going to set up an integral. I'm not going to find the area. So we're going to look at this one a little bit. Okay, so I kind of look at this one like this. If you look at this right here, that would be a region 1. And if we're going to integrate with a dx integral, we would want to go from this point right here, which is 0, 0, to this intersection point right there that we'd need to find. So we're going to integrate the x values there. And then in that interval, the curve in the red, which is 8x, is on top of the curve which is in green, which is 5/2 x. So if I set up that area, so the area of region 1 is going to be represented by the integral from 0 to whatever that is. And so we need to find those limits of integration. Okay, so we're going to go ahead and let's find the intersection points of those two curves. So the two curves are 8x and 5/2 x, so we're going to solve this equation. Okay, one way to solve this equation is multiply both sides by 2. So you would get 16x is equal to 5x. Okay, like that. Okay, so I'm not doing this right either. God, this is embarrassing. God. The intersection of these two curves right there is 8x and 9 minus x squared. Okay, so I need to find the intersection between those two curves. So that's 0. Let's do it this way. So I have x squared plus 8x minus 9 equals 0. Okay, then I factor, so that's x and x, it's 9 and 1, plus minus, so we'd have x equals -9 and x equals 1. Okay, so it looks like probably this curve right here probably is going to be, couldn't be x equals -9, that's got to be x equals 1. So we're going to integrate from 0 to 1. Okay, and the curve on the top of region 1 is the one in red, which is 8x. And then the one that is in green is 5/2 x. So you would have to do that integral, which is a pretty easy integral to do, to find that area of region 1. Okay, now region 2. Okay, we need to figure out this intersection point. So the two curves that are intersecting are 9 minus x squared and 5x 5 over 2x. So we're going to work out 9 minus x squared equals 5 over 2x and solve this equation. It does have a fraction in it, so I'm going to multiply both sides by 2. Okay, so I'm going to have 18 minus 2x squared is equal to 5x. Okay, then I'm going to get everything to one side, so I have 2x squared plus 5x minus 18 equals 0. We'll see if that factors. So I have 2x and x. Let's see, 9, I think 9 and 2 work with a plus there and a minus there. So this would be 2x plus 9 equals 0, or 2x equals negative 9. Divide by 2, you get x equals negative 9 halves. So clearly that's not this intersection point. It's got a positive x value. So x equals 2 should be what that x value is there. So we're going to integrate from 1 to 2, because we're integrating from left to right. And then the curve that's on top in this region 2 is the quadratic 9 minus x squared. The curve that's on the bottom is the 5 halves x there times dx. Okay, so the final total integral that we would work out, we'd have to do two integrals. You'd have to do the total area would be the integral from 0 to 1 of, and so I'm going to go ahead and just put this over 1 and get a common denominator. That would be 16 over 2 minus 5 over 2. So that would be 11 over 2x, like this. And then the second integral would be the integral from 1 to 2 of 9 minus x squared minus 5 halves x times dx. Okay, now I'm not going to work this integral out. That would be what the integral is that would get that area under that curve. Okay, so that'll wrap this up. I made quite a few little stupid mistakes in doing this, and really it's okay that you see that, because it is so easy to make little mistakes when you have problems that have 20 steps in it like that. A lot of this is arithmetic. The key thing is getting the integral set up. That's what you're trying to learn, the difference between a dy dx integral, and then being able to work out breaking up into subregions and effectively working out the arithmetic. Okay, so that will take care of this section.